Thanks everyone for tuning into this session on Linkerd Deep Dive. And tonight we will be exploring the new version of Linkerd 2.10 with our guest speaker Jason Morgan. And if you doesn't whatever the first, if you doesn't know up to this point what service mesh is and what it has to offer, and do you certainly want to need it, and where it fit into this cloud native stack that you already have, we have covered those all topic in our first session, the Linkerd 101. And if you doesn't watch that already, I highly recommend you everybody who watching this go check that out first as well. That is give you the insight of what the service mesh is and why you want to need it. And thank you everyone for tuning into this webinar. I'm your moderator for the session tonight. My name is Saim Safdar. I'm also a community manager at Cloud Native Islamabad. So please join Buoyant's Jason Morgan as he goes deeper into the service mesh with Linkerd. We will dig into the service profile and how they can help with troubleshooting and monitoring. And we also talk about productions deployment strategies. And we also going to talk about what's new in Linkerd 2.10. And we try out the new Linkerd extensions. And Jason Morgan is a developer evangelist from Buoyant. Buoyant is a company who makes Linkerd, and thank you for Jason for showing his time and sharing his knowledge with us tonight. And I hope everyone who watched this session able to understand the new functionality that Linkerd is going to be providing you after that. And I'm really happy for the session. And thank you everyone for tuning into this webinar. Over to you, Jason. And thank you very much. And very happy you showed up. And welcome to the Cloud Native Islamabad. Over to you, Jason. Anik.
Yeah, thanks for having me. So let me go ahead and start a presentation. I've got a very quick set of slides that will ideally run through really fast. Now I've got to share screens first. Also, hey everybody, thanks for joining. Thanks for having me here. So let's present my entire screen because why not? I think this is screen one. That looks like it's it. Okay, sure. Allow. Can y'all see? A slide deck?
Yes, I'm able to see that, and hopefully anybody have some difficulty, you can put them chat on well, but I'm able to see that perfectly.
All right. So this is a deeper dive into Linkerd. So this is ideally going to be an interactive session. What I've done is taken some of the stuff that we didn't go over last time and have it now in demos that we can run through. Please, at any point, feel free to stop me, ask questions, redirect the stuff we're talking about. My name is Jason Morgan. I'm a developer advocate or evangelist over at Buoyant. So it's my job to talk to people about Linkerd and try and convince you to give it a shot. You can find me on Twitter at @RJasonMorgan. You can find me on GitHub at Jason Morgan. You can find me on Slack at JMO. Not real creative about names, so I just went with whatever I could figure out. As a quick recap from last time I was here, what is Linkerd? Linkerd is an extremely lightweight, fast, and security-focused service mesh that is built exclusively for Kubernetes, right? So it is not general purpose. It is specific to meshing up your applications in a kube cluster. We've been in production over 4 years. We have a ton of folks on Slack, and we're always looking for people to come join us. You can find the project on GitHub and give it a star if you like it. We're looking for new contributors, so if you're interested in writing, really advanced networking code in Rust, or you're interested in expanding the feature set that Linkerd has, please come join us. We'd love to get your input. We do regular stable releases, and we just released 2.10. But we also do weekly edge releases if you're looking to see what's latest and greatest. And we are a CNCF project, right? So we're committed to open governance in a neutral home, not dominated by any one company. We're in use from everyone from really big organizations to much smaller organizations. the kind of the design philosophy for Linkerd was to, just do enough to be useful and nothing more, right? So our goal here is that when you install Linkerd, we don't break your kube cluster. We don't require you to learn a whole new language or a whole new way of working, right? You install Linkerd, it just works. You can start getting some benefit about your environment. We stay really lightweight so that the performance and resource, right? So you're not going to find 20, 30 plus custom resource definitions to use Linkerd. There are two, and we're going to talk about one of the two today. And we make security and sane defaults the default when you install it. I'm not going to go too much there. If it makes sense, I'm going to go through the last couple of releases of Kubernetes of Linkerd on Kubernetes. Sound good? I'll take that as a yes. Linkerd 2.8, right? This is where multi-cluster came out with Linkerd. It's good and important functionality, and that's kind of where this thing came in. In 2.9, we expanded the MTLS story inside Linkerd, so the Linkerd proxy is able to extend that mutual TLS of encryption and identity across all your TCP traffic inside of a cluster. We also added ARM support, so if you're looking to run Linkerd in AWS Graviton, or if you've got Raspberry Pi clusters or whatever, you can install that. You can install that today. We also made the proxy runtime multi-core to allow you to do more with it if you need that, as well as support for service topologies. 2.10, that's a bit of what I'm going to show you today. But in 2.10, what we did is we took apart that control plane and we made it a bit more extensible. So you're going to see the installs when we go in that the default control plane is really just the bare minimum needed to do the work. And it doesn't include things like a UI or a monitoring stack. That's in the Viz extension, which you're going to see me install today. There's also a Jaeger extension for if you're doing distributed tracing, and the multi-cluster extension, which is a separate set of tooling for if you're going to do Linkerd multi-cluster. You can also write extensions from third parties. So Buoyant is included now, the Buoyant Cloud extension that you can install and use with Linkerd. And yeah, anybody else can write their own extensions. And extensions work with that same functionality you were used to in the base Linkerd CLI, and you'll see that when we get to it. 2.10, we also changed the way we did skip ports to now include this new thing called Opaque Ports, where you can tell Linkerd that a certain traffic you just want built as a layer 4 connection between two endpoints, and you don't want it to do any sort of protocol detection, and that'll work. And we also gain the ability to now multi-cluster any TCP connection. So it doesn't have to be an HTTP or Grpc app. Whatever that connection is, you can work it multi-cluster. So just to expand on our theme of last time, if you're looking for more info, I'm going to do a lot of stuff out of the Linkerd docs page. So the examples that I've built are all really built off things that we already have in our docs, and I'm going to show you some of that as we go. You can find us on GitHub, github.com/Linkerd/Linkerd2. Love to hear from you if you have any ideas or suggestions. And if you're interested in joining our Slack, it is slack.linkerd.io, and we're always looking for new members. It's a very active community. It's a very active community, and I'll hold that for a minute. I didn't actually see anything pop up in the chat while I was there. Does anybody have any questions or anything they want me to go on before we hop over to the demo? All right. So I promised a deeper dive. So I figured I'd start with just doing a Helm install. So let me actually move this thing over here. Let's do a Helm install. So for those that were here last time, we did the Linkerd install using the Linkerd CLI, right? So I'm gonna just expand something down here. If you see in the bottom right corner, right? What we did is we had a cluster and we typed, Linkerd install, and then we piped that over to kubectl apply. we created YAML manifests and went through the process of building things out. Now, one of the things I talked about, or may have talked about, was that the Linkerd install generates a bunch of YAML templates or YAML documents that we hand off to the Kubernetes API. And to generate those YAML templates, it uses, or that YAML, it uses the exact same templates that the Helm install uses. So the arguments that you pass to the CLI can be passed to Helm and vice versa. So let's actually do the Helm install or install Linkerd with Helm. You see here, I've got a kubectl git pods running where it's listing all the pods and all the namespaces. So you can see that I'm not tricking anybody. We're going to add the Linkerd stable repo. There's also an edge repo if you want to install it, install the edge. We're going to do a Helm repo update just to get our Helm repositories up to date. Great. And let's actually go ahead and install Linkerd 2. So the first thing you're going to notice about the Linkerd install that is different in Helm than via the CLI is with Helm, you have to have pre-generated all your certificates, right? So we have all the steps in our docs, and let me actually go over here and just show you where we get this from. So if you go to Linkerd Helm install, right, it tells you about adding the repos as well as talking about the certificates you need to use, and then it provides a link to some instructions for generating certs if you're doing that for the first time. And again, this is all here in the Linkerd docs page. So we're going to go ahead and run that install. You'll see the output's actually fairly similar to what you get when you run the Linkerd install command. And now I've got a new namespace called Linkerd with my components coming up. So just like before, I can use the Linkerd CLI to actually tell me when this cluster is ready. So because these pods are still building out and initializing, I've got Linkerd check blocking me and waiting for this to become ready. Let's go ahead and clear this out over here. Is this big enough? Can everyone see the writing? Sorry, let me pop over. I can't actually see the screen. And are there any questions so far? Thank you. Girish, is that how I say it? Girish? Awesome. So far, so good. All right, cool. All right, with that, so the, whatever Linkerd identity finished, so it's moving on to the next component. We're waiting for the controller to come up. One thing that's notable when you're doing a Linkerd install, if you're installing for HA at the command line, you just add a flag, right? An HA flag. Oops. All right. I have to ignore the cluster because it's used. So I can just add the HA flag with Helm. Of course, there's no HA flag. Instead, we just use a production values.yaml file to get going, which is stored right there in the same Helm chart. With that being done, right? I've got my Linkerd install, but if I go to do the Linkerd dashboard command, it's going to fail because we don't yet have Viz the Viz component installed. All right, so we're going to go ahead and install that. So now with the breakup of these components, your dashboard, your multi-cluster, your tracing are all put in their own Helm charts under this Linkerd repo. So we'll install Linkerd Viz. It's that pop up. If I look down below, I can do Helm ls. Get respects -a. Yep, we can see that I've got the Linkerd chart installed. I've got traffic, which comes with my K3s cluster, and I've now got Viz being installed. So now the extensions, they each come with their own check. So we can type Linkerd Viz check, and again, it's going to wait for this environment to be ready to go. All right, Linkerd Viz is up. Let's go ahead and pop open that dashboard and see what our environment looks like now. So we can take a look. We've got, the Linkerd system, the Linkerd Viz system, or namespace. We can look at what apps are configured. We can see Prometheus talking to everybody. Metrics also talking to Prometheus. We can see the current, success rate, number of requests, and latency by bucket. And my Grafana instance is up. So if I want to get some details about any given portion of this, I can just ask for Grafana. So let's go check out Linkerd Viz. And here I can see the metrics that Prometheus is collecting in a default view in the default Grafana dashboard. Just before we move on to anything else, I'm going to install a couple apps. So I'm gonna add in this pod info application. So you're going to see a new app get deployed here, and then we're also going to add in emoji Voto, and we're going to do a Linkerd inject. Right, so Linkerd inject is one way to get proxy injection in. So what it does is it adds an annotation to all your deployments to say, hey, please inject the proxy on this app, and then we're going to hand that off to kubectl, and that's it. Any questions about the Helm charts? We can go ahead and edit the pod info namespace. Right, we can add an annotation here. So annotation. It could be io/inject. I don't know why I always get the indentation wrong when I do this. So we've got a new annotation, and then we can get our pods, we can get the pods inside that pod info namespace. So you can see none of them, if we look over here, we see none of our pods in the pod info namespace. So if we get pods, pod info, you can see none of them are injected because they've each only got one pod running. So we're gonna fix that. We're gonna delete the pods in the namespace. And as they come back up, they're all restarting with now 2 containers. Again, going back to our Linkerd dashboard. We can now see some more stuff going on, right? And get some insights into, emoji Voto, what our traffic flow looks like. So in emoji Voto, I've got 4 components. We can see who's talking to what. We can also see where it's healthy, where it's unhealthy, right? So emoji and VoteBot are pretty happy, but voting and web are having some failures. And we're gonna dig in and figure out why here in a minute. Sound good? So no questions on Helm. I get that. Do we want to? Is it okay to hop into service profiles now? Let me actually pull this one out into another window so I don't have the same confusion anymore. All right, let's pop into service profiles and see what that adds. So we'll break out of this dashboard because we're not going to need it. All right, so let's take a peek. So I've got a new app that I'm going to add into this environment, right? It's going to be called Books app. So let's actually rerun our Linkerd dashboard. Oops. Linkerd Viz. So now when I'm calling the dashboard, instead of just Linkerd dashboard, I call Linkerd Viz dashboard. We're gonna create a new namespace, call it Books app, and then we're gonna deploy an application here. So we've got our sample apps at run.linkerd.io, and we're going to pass that right over to Books app apply. Great. I can do KNS Books app. Right, so I'm just changing my namespace. Okay, get pods. I see I've got some apps coming up. Let's just watch. Once they're ready, we can go ahead and port forward. So, okay, port dash forward. It's like kget service. So again, we've got our pods. We're going to forward that web service. We're going to see now if I go to localhost 7000. Oops, not 700. Go to localhost 7000. I've got a new application. Cool. Let's make a new book. Let's call it Cloud Native Islamabad. Sure, it was written by Margaret Atwood. Why not? And there are 35 pages. Let's add a book. That worked. Cool. Let's go back. Let's try one more. This one's written by David Mitchell, and there's 10 pages. This isn't supposed to work every time. Hold on, one more time. Also David Mitchell, 1 page. There we go. Oh, shoot, we've got some failure, right? And we need to figure out how to get it working. If I just retry a couple times, we're going to see that it works eventually. That's cool. But like, what's been going on and why? I can look in the dashboard, but Books app, it's not meshed. So I have really no understanding of what's going on. But my app's working, it's working right now. So let's get that fixed. So let's see how we can understand what happened and why. Got our port forward, great. Yep. So to start off with, we're just going to inject these deployments, right? So we're going to tell the mesh to start managing this traffic. Once we do that, Kubernetes sees the new deployments coming up. It's going to spin up our pods. And suddenly, it's going to start tearing down the old versions of it now that it's got the new injected pods. All right, now before I do anything, let's just take a look at this dashboard once again. So now, I refresh, and I'm starting to see some data, right? I've got success rates by component. I've got the number of requests. I've got a view that I didn't have before about what's going on with Books app. And I can even see the structure. Okay, I've got a web app. I've got authors and books. It's actually one more that's a little traffic generator. Yeah, there we go. So I've got my traffic generator. It's talking to web app, which is talking to authors and books. And authors and books are talking to each other to do something. And while traffic's pretty happy, nothing else is succeeding the way I'd want it to. So like, what are we going to do, right? Well, we can take a peek at web app. We can see, what components it's got here and what's going on. I can see I can see myself sending it traffic. Right, so I can see myself sending it traffic, and I can actually take a look at the live calls that are happening to this environment and see, maybe get a clue as to what the problem is here, right? I can see there's a lot of traffic, but I don't know what my problem is. If I click on route metrics, right, I've only got this default route, which is basically a catch-all for everything that's coming through this environment. So we can fix it. We can fix this view, right, and get better details of what our application is doing with a resource called a service profile. So this is Linkerd's big custom resource definition. So let's show how to generate that. Shoot, here we go. So what I can do is I can take the Swagger file. So if it's written, with an open API spec, and we've got a Swagger doc, we can grab that Swagger doc and then create a profile for it. Also, if we want, we can build a profile just by watching traffic to an application, or if it's a gRPC, or if it's using gRPC, we can take that proto file, that .proto file, and generate a service profile. So when we create a service profile, what we get essentially is, for the name of that service, webapp.booksapp.service.cluster.local, I've got a bunch of details on the various routes that this application has and what they're doing, right? And when I hand that off to my service mesh, so we're just going to run the command again, but we're gonna create our new custom object. So when I create my new custom object, what I get all of a sudden is new route metrics, right? So instead of just default now, what I've got is a bunch of new paths, right? So I've got the individual paths within my web app, right? And I've got specific statistics on what's going on. And again, it's pretty easy to see, but if I look at the success rate, looks like editing a book doesn't work that often, right? Same thing, creating books doesn't seem to work that often, right? But everything else, all my other calls are fairly straightforward. Is this making sense? Do y'all get what we're doing here?
Yes, Jason. And can you dive a deeper on what service profile is and what's happening inside that server profile?
Yeah. So what I'm gonna tell everybody, right, because this is going to be a short demo, right? But when you go to do it yourself, go check out again in our docs. It's going to talk a lot about this, and I think my favorite page on it is just debugging HTTP applications with per route metrics. But you can look at service profiles. Where is it? Got it. Setting up service profiles. You can dig in here as well to understand what they're doing and how they work. So this will talk about doing it with different application types, right? Let me actually put some of these in the chat because they're worth checking out. Oops, that was sorry, that was not what I intended to send. I copied instead of pasted here. Back, forward. Here we go. Well, if anyone wants to read my new Stack articles, go over there. So there's our setting up service profiles, and here is the specific task. This is basically the demo that I'm walking you through, right? The nice thing about Linkerd, it's got pretty darn good documentation, so you can go ahead and actually do a lot of stuff just by looking at the docs, right? It's one of the reasons that it's fairly simple to run. That and it really isn't a ton of overhead, right? I didn't have to change the way Books app worked so that I could add to the mesh, right? I just injected a proxy, didn't create any new objects. We were just good to go. So while I created that Swagger spec or that service profile, so let me just go over here. Watch kubectl get service profile, right? So again, this is our new CRD. So if I look at it, I've got one for Books app, but there are other components in this application, right? Go back to my Linkerd here. I've got a number of things here in Books app. So if I go back, Books app, I've got web app done, but I need authors and books so that I really have a good sense. Pop into authors as an example and look for route metrics, right? I've still just got the default. So let's teach the mesh about authors and books. So now authors has popped up. I've got a new service profile. And again, we're just going to take the Swagger doc, because Books app's well instrumented, and there's a bunch of Swagger docs. We're going to get that for books as well. Right now, I've got the ability right? You saw me going through the dashboard, but I've also got the ability to use the Linkerd Viz CLI and just get route information right from the CLI. So that same stuff you saw me like navigating through the GUI to get, I can get these details right here. And I can already see, hey, listen, like, the routes for the service web app, books and books edit, like there's something wrong, right? So I can go to my developer, or the teams that run books app, and I can be like, yo, let's see what's going on with these calls. Like you can point them not just that, hey, your app's failing intermittently, but specifically this call inside the API fails. We can also look, from the web app deployment to service books to make it a little bit more specific. It cuts down even more, right? We've got this sense of exactly where we're having problems, and we've got this default route which counts everything that doesn't fit into one of our pre-made routes, right? Or one of the routes defined when we created the service profile. And again, we can look from the books deployment to authors, where are we having issues, right? Well, when books is talking to authors, this, get author ID JSON, it seems to fail periodically. What has happened here? All right, cool. We don't actually need this up anymore. All right, so seeing that, right? Like we've got a pretty clear idea. Sorry, we've got a pretty clear idea that something's going on, right? And we're getting failures with this call to our authors, this author service. So what we can do, right? Because they seem to be intermittent, right? What we can do is we can tell Linkerd that, hey, when you see a problem with our authors app, right? We're seeing the problem down here on this call, right? Head authors ID JSON. So we just want to retry that periodically. Now let me do some copying and pasting so I don't mistype here. Right, so what we're going to do is we're going to edit this service profile. And we're going to say, we're going to add a property. And say, is retryable true? Right, so this is a safe call to retry. We tell that to the service mesh. Hey, look at that. And now, it's actually pretty cool to watch this. So if we do a watch on this command, we're going to see is the failure rate. Let me just make this a little bit smaller so it formats nicer. What we see here is the effective success rate for this app is going to start climbing, right? Because even though it's going to still fail half the time, right, Linkerd retries it, right, and has been told to safely retry it. So my app, now, like I didn't make any code changes to my application. I've still got whatever fault I had, right, in this environment. But effectively, for my customers, we're seeing a retry rate turn up to 100% or rapidly approaching 100%. So we can give some intelligence about this application to the mesh. Right, so that's cool, right? But I'm also seeing that, like, as I do this retry, right, what happens is my latency starts to climb up, right, for this application. So let me just change our watch command here on the side. Right, my latency, you see even here, right? Like before it was like 30 seconds at P99, now it's all the way up to 97, right? And that latency is climbing because those retries are causing me to delay, right? Because it runs through and does the same thing again. So what we can do is we can edit, people talk all the time about circuit breaking, in Linkerd, and like we don't have the sort of circuit breaking where you can say, hey, don't if you see this service getting more than 10,000 calls a minute, don't send anything over. But you do have the ability to turn on retries and set up timeouts. So we're going to edit Books app. We're going to say that, hey, listen, 95 millisecond for P99 latency is way too much. So let's bring that down, right? So I can go down here and set a timeout on this put condition. So timeout, right? 25 milliseconds is all I want you to handle, right? And if it goes above 25, quit it, right? This isn't worth it. Right, I edit that, and you're going to immediately see the failure rate, or the success rate, is going to go down, but my failure rate, but my latency is going to drop. So let's go. Yeah, that's the wrong call over there. That's the right one. Yeah, so this is just the same call but wide. Yeah, here we go. My success rate has started coming down. There we go. Took a while. My success rate is dropping because Linkerd is basically sending back a 500 saying, hey, listen, this didn't work. But my latency is staying lower. Is that making sense? Can we do circuit breaker or exponential backoff? So no. So the exponential backoff, no, but you can do circuit breaking in the sense of timeouts. Yeah, so you can do circuit breaking in the sense of timeouts. And of course, if Linkerd sees that a given app or service is unavailable, it's going to send you a 500 right away. So if I try and call a mesh service where the nodes are down, right, or failing their health checks, like we're not gonna keep sending it and just waiting forever, right? Linkerd has a default timeout built into it of I think 10 seconds, and you can adjust that timeout on a per route basis. And again, like when it does the retries, right, there's actually great documentation on retries. So let me just see where this sits. Configuring retries. So this is a really cool one. But the way Linkerd does retries keeps you safe from like these retry storms, right? Because it's a longer topic. You can see it in depth here under configuring retries and the way that works. Yeah, basically it just checks which requests should be retried and how many times should we be retried. So let's go back. Yeah, so that's service profiles. Yeah, that's service profiles and how you might use them. And then we've got how you'd use that to troubleshoot an application, right? Again, we're able to see from Books app that this was the issue. So let's create a new book here. Let's call it CNI 5. Keep going with David Mitchell. Let's go NK Jemison. 700 pages. Oh, sorry, I'm not port forwarding the service anymore. So that's not going to work because I turned off my port forward. But anyway, we're able to go in for our applications, see the given route metrics, see that success, right? And adjust to, adjust what's happening based on what we want to see have happen. Right, and we've got Books app's overall success rate increase from where it was just by making some changes to the way the mesh operates. Make sense? Sound valuable? Can you really see the error from the app? Can you say that another way, Girish? Or can you ask that another way? Sorry.
And also just
oh, so the issue with the app. Oh yeah, okay, great. Let's talk about that. So the issue with the application. Yeah, so we don't know what the issue is with the application, but we know that when we made a call to this path, it was failing about half the time, right? Right. So when we tried to add a new book, that failed about half the time because there was an issue with the author service, right? And we can see what calls within author service are the ones having the problem, right? Specifically this path. So I don't know what about the app is calling this or is making this call fail periodically, but I know that this is exactly where my problem is. And I know that I can change this effective success rate by adding in retries. So by telling the mesh to retry these calls, I can make it so that I don't see this same amount of failures overall.
Yes, and actually, I think this app is written in a way that if you call first time, it's give you the result of 500, and then if you call again, then it's give you the 200 response of that. So one of the time is failing, and next time is going to the passing, to able to
Almost.
predict you
Yeah.
that that's the fault tolerance behavior of the service mesh. Then you can get with these kind of apps.
Yeah, basically what it does is it has a 50% chance of failing on every call, right? So that's why that timeout, by adding that timeout, we reduce the overall latency that we'd see, because something could fail multiple times in a row, right? And then that would just make it take longer and longer and longer. But adding a timeout now, if you fail, if it takes over 25 milliseconds, we just cut out no matter what. So some other examples of things we could use to just diagnose some stuff, right? Emoji Voto actually has way too high a rate, so I don't know what's going on here. But Emoji Voto tends to fail pretty often. It should be around 15% of the time. And we can go take a look, right? So yeah, here we are. Our success rates are plummeting once again. We can go take a look at Emoji Voto, another app that we have running, right? And we can start to see, just by looking at these raw calls, what all paths are having issues, right? So again, I can see when and this is a gRPC application, but I can see that when applications call the Emoji Voto, the web service from the Emoji Voto, that when it fails some not insignificant portion of the time, and really when it gets calls from VoteBot to just vote overall, right? We see that only hits, right now around 70% successful. But then I look at further on, like when it sends a call to the voting app, right, to this vote donut path within the voting app, it fails 100% of the time. So I've immediately got a sense of where my problem is inside the application code. And we can go over to Emoji Voto. We can go over to the Emoji Voto app. We can look at the voting service, and we can actually go in and see like what's going on. This is the wrong one. Ugh. Yeah, here we go, right? So I can see that when I vote normally, right, it returns a happy vote, but vote donut, right, which corresponds to our failing call here, vote donut. It's built to just return an error. So it gives us a pointer for where to go in our code to find the issue. Does that make sense? That being said, Linkerd is not going to tell you, hey, your app's badly written in this case or that case. It's going to give you some insights that you can use to go and check out your application. And again, for this one, right, because Emoji Voto is a gRPC app, right, like I can profile Emoji Voto a number of different ways. So I could build a profile by watching traffic, by looking at a Swagger doc, or by looking at a protocol file. So we could take, we look at Emoji Voto, we've got, this proto file. I could take voting, and I could build a service profile from it just by grabbing this app. So we grab our raw here. Right, again, just to show I'm not making anything up, I look at, oops, this is web. I want to look at voting. I look at my rep metrics, and I've got nothing but the default because we haven't created a service profile. But if we want to on voting, so Linkerd service profile. I never remember the command right off the top of my head. So profile, yeah, there we go. -n emoji photo. We're going to do -- proto. Oh, sorry, hold on. -- proto, and then we're going to say voting -service. Let me just confirm that's the name. Get service -n. Yeah, voting -service. I have to give it the input, so give me just 1 sec. It's going to look weird. Curl space type. Right, and so that'll basically read that protobuf file, and it's a hugely long. It's a very strangely written app, but it's a hugely long protobuf file or service profile. But it tells us every single route, and now we can hand this back. Okay, apply -f, and we're going to say -n emoji photo. Oh, sorry. Right, we've got a new service profile, so we're going to do k-get service profile. Sorry, -n emoji photo. And we see that there's a new voting service. And here, right, shock, I've got my full route metrics, right? So as we continue to call, we'll see success rates for voting. Where'd you go? There we go, route metrics. Right now, most apps don't get called very often, but we can go sort by success rate. And again, right away, right, by adding this profile, I can see that the vote donut call is having this issue. Same thing I can see when a particular path has a greater latency, right? So that's kind of the whole story. So that was most of what I wanted to show. Obviously, we've got a few minutes, so if anyone has questions or something you'd like to dig deeper into, I'd love to hop in and peek at something.
Yeah, it's awesome, the stuff that you're showing today. But one question is that if somebody, let's say that's like Linkerd 2.10 version, and then if so it's got to be, you can extend the, let's say, for first version of the, you have monitoring and all the tools set up for you, but now you have a fine grained control. If you want those, you can inject those up, and if you doesn't want those, you have that ability as well.
Yeah, absolutely. Yeah, so just decomposing that control plane. And Girish had a question on multi-cluster.
Yes, Jason. Yeah, so I had set up the multi-cluster as given in the getting started guide in this particular link. So I understand that from one cluster to talk to another cluster, we basically use a proxy, right? Or a gateway, if I'm correct. It's basically the service. Yeah, the service mirroring and the gateway feature. So I understand that. I want to know, like, how does the request will get forwarded from the gateway to the actual pod? So I understand from the front end, right? It will go to pod info of east cluster, which is a service mirror, and then it will go to the gateway. And from gateway, how does it go to the actual pod?
Like, how does it go to the pod on the other cluster?
Yes. So the gateway I'm using is just the Linkerd gateway. It's not any other ingress or ambassador and all. So I think it's a gateway connected mode. Yeah.
Yeah. So it basically it just creates a connection, over the network. So it's the two, the one gateway is going to talk to the other gateway, and they're going to set up a tunnel just between them, right? An MTLS tunnel, and then it's going to send the traffic over. And then when it gets to the other side, the Linkerd proxy on the other end is just going to read that request, see that it's supposed to go to a pod in, the backend service A, and it's just going to send it over. So this would be a lot easier if I had my whiteboard. I should have brought my whiteboard, but it just, it treats that connection between the two gateways like a little VPN tunnel, right? It's a HTTPS connection, forwards the packets over there, and then the proxy on the other side sees, okay, where's this supposed to go? It's going to, backend service A, and then it sends it over to one of the pods from backend service A. Did that help?
So the proxy, how does it send it to the pod? Like, is it through an IP address or through a port?
Yeah, both, an IP address and a port. So so the way the pods, just so you know, the way a proxy finds a pod in a service is it keeps a list of all the members of a given service, and then it looks at those members and that are local, and then it sends it grabs any two of those members, it compares which one is faster, and it sends it to the faster one. So this is all about Linkerd's routing, right? So this is where you can get into some really cool stuff around EWMA. So let me see if we can, let me just Google it, 'cause it's a little bit easier. Linkerd EWMA. So this is, not EWMA, sorry. So it's this, okay, well here, this will talk about it in a lot more depth. But essentially, it just takes, the gateway takes it from one cluster to the other cluster, and then the proxy on the far side just looks for the right target and sends it over to the right target in its cluster, right? And it sends it with an IP and a port that it's supposed to go on. Then the proxy, the receiving side proxy is going to grab that information, or grab that connection, unpack it appropriately, and forward it to the app. Make any sense?
Jason?
Yeah.
Yeah, thanks for the presentation. So I just basically got started into Linkerd. Thanks for the talk. Since we already have, for example, like what I mean to say is like Kubernetes, then we have Prometheus, Grafana, which gives a bit of insight. Where does Linkerd shine comparing those, and what would be the best fit to put in Linkerd, like in a given enterprise? Jason?
Yeah, so it's a great question. So let's just do something real quick. So let me share my screen again. Share entire screen. Select, allow. All right, so let's go ahead and so if you've already got pods, right, and you're getting metrics from those pods. So if I do kget pods -n pod info as an example, right? So I'm just going to go ahead and delete this namespace ns pod info. We're going to delete it and we're going to recreate it. So what happens here is when I add an app into my mesh, right? What I get is not just metrics, because metrics are nice, right? But if I look at web app, authors, or books, I have the exact same metrics in the exact same format for all of them. And I also have details about how they talk to each other, right? So just because I have an app, right, doesn't mean that I have everything I want to know about that application. So by adding it to my service mesh, I get better reliability for my connections. I get better performance because of the way Linkerd handles routing. If I'm using a gRPC applications, so is it Raju?
Yes, Jason.
So Raju, if I've got gRPC applications, right, by default, they're not gonna, like, those connections aren't gonna load balance on their own, right? So if you're using gRPC apps and you put it in Linkerd, you've now got gRPC load balancing that you wouldn't have had before. And again, you have the ability to build out these service profiles to get more insight. So stepping back, right, what I'm trying to say is any app that you add in, right, especially one that's doing HTTP or gRPC, you're going to get standard common metrics for every single application by putting in the mesh. you're also going to have the ability to show your developers, right, where problems are arising and what performance looks like, right? In this common way across every service inside the mesh. That's really, I guess, where I would start. And the nice thing is the cost of adding in Linkerd, right? If I go in and, so I've got this done, right? But I go and do that pod info deployment again. So give me 1 second. I got to pull up. Got to pull some up. So let's go and do that pod info deployment. Right, like this works right now, right at the gate. So if I do k port forward, -n pod info, 8080, and it's going to be, service / front end. I think it's 8080, 80. I don't know, 8080. Right, so this works, right? This is a working app. Right, so I can take my working app, I can add it to the mesh, right? So I don't have any metrics on it. So I go in here, I look at pod info, right? There's nothing inside my mesh, so I don't have any stats. I can take that same app now. Let's break out of this. K get deploy -m pod info -o YAML. Inject dash. Oops. Right, I inject it. Let's see that port forward again. Hold on, let's wait for some pods to come up. K get pods -m is web up. Yeah, so front end's up. Cool. So I didn't lose, I didn't lose the ability to route traffic. Right, so I don't lose anything if I already have a running app, but now I've got details, I've got a service map, I've got details about the success rate, all those golden metrics I need to see how I'm behaving. And if I do, say I start getting an error, so this is kind of a neat app that'll allow you to do error codes. So if I start getting some errors, right, some 500s, now because my app is in this mesh, I can take a look at it and I can see that the success rate has changed. Don't make me a liar, app. Maybe it's pod info. Right, I can start to see, there we go. I can start to see some failed requests, right, coming from the front end.
Yeah.
Turns out 500 is no good. I have to actually give a number. So, you get what I'm saying?
Yeah, yeah.
So that's kind of the why. So your best use cases are if you have a Grpc app or an HTTP app, and you want to make it just easier to operate. And the cost to add in Linkerd into your environment is really low, right? Like I've heard from multiple folks, like the longest I've heard to implement Linkerd in a production state is a week, right? In terms of engineering time, which isn't huge. And you're going to be able to take it into your dev environments same day. Or you can just add it in, use it, see if you like that data. Imagine you just use it in your like your user acceptance testing environment, right? You'll get better details about your apps right out of the gate by putting it in there, right? And if you take it to production, you're going to get better details, and you're going to get faster apps and more resilient apps.
Mm-hmm. Thanks. It was super awesome to see. Yeah.
Cool. I know we're over time, and I'm really sorry, folks. I just wanted to show that before we left.
No, thank you, Radim. One last question that from my side, because so one of the best use cases to use Linkerd third-party extensions.
Well, thanks for that. Thanks for that queue up. So right now, the only third-party extension that I know of is the Buoyant Cloud extension. So if you're using Linkerd and you're looking at, hey, I'd like to get a really nice application-centric view of my environments, even if they're multi-cluster, then the Linkerd Buoyant extension will get you access to Buoyant Cloud. There's a free tier of Buoyant Cloud where you can start using it and get some insights. And then of course you can expand out what you put in. You can pay for Buoyant Cloud from Buoyant, and we'll start adding like the ability to add in more applications.
Thank you very much. We are just out of time right now, but really enjoy the session and what kind of the new feature that it does with. I'm really tried that out tonight after this session, and it's going to be very flexible things that we can doing on the CLI as well, and this third-party extension and many other features that are listed here. And also the Linkerd is doing a session on 2.10 version as well, the Linkerd community as well, and that's going to be hosted in CNCF. And if you watch that, I put them in the chat here in the YouTube channel if you're watching that from YouTube, and you can grab the link and register for the session, and you can do a cool kind of stuff that we don't able to get tonight. You can get to that session as well, and you learn a ton of cool stuff from there. But really thank you for the Jason's talk, and ton of new things from Jason, and hope we try that out, and hope we catch up again, Jason. Thank you very much, Jason, and really happy and you showed up and share your knowledge, share your time, share your energy. Thanks, Jason, and thanks to everyone who joined the session today.
Yeah. Thanks for having me. This was fantastic, as per usual. And at any time y'all have me back, I'm happy to come back.
Thank you. Bye.